Hi, this is Jack from Maths Forge, and in today's lesson we're going to be solving equations graphically. So let's take a look at our first example. Here we're being asked to find x when 3x plus 2 is equal to negative 4. So how you approach this is as follows. Your equation that's given to you, 3x plus 2 is equal to negative 4, has two parts to it. It has the left-hand side of the equation and the right-hand side. For the left-hand side of the equation, I'm going to take this and I'm going to equal it to y. So this is going to give us y is equal to 3x plus 2. I'm going to do the same with the right-hand side of this equation. So this is going to be y is equal to negative 4. Now, the reason we have set them equal to y is because we're going to draw the lines for these equations out onto this grid. Where these lines intersect each other is the solution to this equation. Let me show you what that looks like. Now let's go ahead and draw this line out on the grid. To draw this line out, I'm going to first build a table of y and x values, and I'm going to get my paired coordinates from here. So I'm going to pick -1, 0, and 1. Now, when x is equal to -1, y is equal to 3 times -1, which is negative 3, plus 2, which is also negative 1. When x is equal to 0, y is equal to 3 times 0, which is 0, plus 2, which is 2. And of course, when x is equal to 1, y is equal to 3 times 1, which is 3, plus 2, which is 5. And so now we have some paired coordinates here. Let's use the first coordinate, which is going to be -1 and 1, so -1 and 1 is here. The second coordinate is 0 and 2, so 0 on the x, 2 on the y. And the third coordinate is 1 at the x and 5 on the y, so 1 on the x and 5 on the y. And now if we connect these points together, we should get the line for the equation y equals 3x plus 2, and here it is. Now for the line y equals negative 4, this is straightforward. This is going to be a horizontal line that cuts the y-axis at negative 4. So it's going to look like this. And here are our two lines. This is the line of y equals 3x plus 2. And this is the line of y equals negative 4. Now where they intercept each other, this point here, is the solution to your equation. So they're asking us to find x when 3x plus 2 is equal to negative 4. So the x coordinate of where they intercept, which is negative 2, you can see it from here, the x coordinate of their interception is negative 2. This is the solution to this equation. And if we check our answer, there it is. Now let's do a 2-star example. Here they're asking us to find x and y for these two equations here. So I'm actually going to draw this line in a different way. I'm going to start where my y-intercept is, which is plus 2. I'm then going to use my gradient to draw the next part of this line. So my gradient here is 2. And a gradient of 2 can be written as a fraction as 2 over 1. Now, if you remember how to find your gradients, it's the difference in y divided by the difference in x, or rise over run. So this number here at the top is how much you move up or down by to stay on your line. Since it's positive 2, we're moving up by 2. So this is going to be up by 2. And this denominator here is how much you move to the left or to the right by. Since it's a positive 1, we're going to move to the right by 1. And let me show you what this gradient looks like when you're drawing it out. So we're going to have 1 to the right and 2 up. 1 to the right and 2 up. So it's going to kind of look like this. And if we work backwards, it's going to be 1 to the left and 2 down. 1 to the left and 2 down. 1 to the left and 2 down. And it kind of looks like this. So this is the line of y equals 2x plus 2. And now if we do the line of y equals negative 3x minus 3, it intercepts at negative 3. So that's going to be here, intercepts the y-axis at negative 3. And it has a gradient of negative 3, which can be written as a fraction as negative 3 over 1. Since the numerator is a negative, it's going to go down by 3. And the denominator is a positive, so it's going to go to the right. And let's see what this line looks like. So we're going to start from the y-intercept minus 3. So it's 1 to the right and 3 down. 1, 2, 3. So about here. Or 1 to the left and 3 up. 1 to the left and 1, 2, 3 up. 1 to the left and 1, 2, 3 up. 1 to the left and 1, 2, 3 up. So about here. And these are the two lines for these two equations. Now, where they intersect is the solution to this problem. So they're asking us to find x and y for these two equations. Well, the x and y coordinates of where they intercept is the solution. So the x coordinate is going to be -1 since it's sitting on -1. And the y coordinate is going to be 0, since if you go to the y-axis, it's sitting at 0, their intersection point. And if we check our answer, there it is. Now, you didn't have to draw the graphs in this way. You could have drawn a table to find the x and y valued pair coordinates and then plot them out that way. But I prefer to do it this way on this occasion. Now we'll do a 3-star example. Here we're being asked to find x and y when this quadratic and this linear equation is drawn graphically. So how can we do this? Well, first things first, let's draw our y equals 2x plus 3. So it has a y-intercept of 3, positive 3, and it has a gradient of 2, which means that it can be written as 2 over 1. So it's going to be 2 up and 1 to the right. And from our y-intercept, this is going to be 1 to the right and 2 up, like this. And so if we carry on this line, so 1 to the left and 2 down, 1 to the left and 2 down, 1 to the left and 2 down, it looks like this. So this is our line for y equals 2x plus 3. Now we need to draw our graph for y equals x squared plus 2x plus 3. How we do this is as follows. So now to plot my quadratic graph, I'm going to use an x and a y table to do this. I'm going to make sure I have enough room for 6 values. And now I'm going to choose my values for x. So I'm going to choose -2, -1, 0, 1, 2, and 3. And when we input -2 into x, we get the following for y. -2 to the power of 2. So we're replacing the x here with the x values that we're substituting it for. This is going to give us 4 plus 2 times -2, which is -4, plus 3. So our y value when x is -2 is 3, because of course plus and a minus make a minus. 4 minus 4 is 0, plus the 3 is just 3. If we do this for -1, we'll get the following. 2. If we do this for 0, x is 0, we'll get a y value of 3. And if we do this for 1, we'll get a y value of 6. And if we do this for 2, we'll get a y value of 11. And finally, if we do this for 3, we'll get a y value of 18. Now, if you take a look at your grid, it can only go up to 5 and down to -5. So we actually can't use the last 3 values since they have values greater than 5. So I'm now going to write these coordinates in, -2 and 3. So -2 and 3. -1 and 2, and 0 and 3. So I know that my graph is going to look something like this. And their intersection point is here, which is going to have an x and the y coordinate of 0 and 3. So finding x and y for this is going to be as follows. X is equal to 0 when y is equal to 3. And if we check our answer, there it is. Now, if this curve was to intersect with 2 parts of this line, then we will have 4 solutions in total rather than 2. Since this curve is only intersecting with 1 part of this line, then we have 1 set of coordinates as our solution and therefore 2 solutions, an x value and the y value. But if it did intersect with 2 points on this line, then you'd have 4 solutions because you'd have 2 coordinates. And that's it for our lesson on solving equations graphically.